Hello, very good afternoon to everyone. Welcome to NUS Department of Electrical and Computer Engineering. My name is Arthur. I'm the Deputy Head looking after External Relations and Outreach. So we have prepared for you today a brief overview of our curriculum, as well as we also have a student panel that will share with you their experience and the type of modules that they do in NUS. And then later on, for those of you who want to visit the lab, you can visit the Satellite Center, and there's also a hands-on lab where you can experience some of the things that our students will be doing when you join NUS. So let me first introduce our head of department, Professor Biblab, to give his welcome address. Thank you.
Thanks. Thanks, Arthur. First of all, good afternoon, everyone. A very warm welcome, even though it's pretty hot outside, to the Department of Electrical and Computer Engineering on behalf of the staff, faculty, and current students in the department. The purpose, as my colleague Arthur just mentioned, is so we want to give you an overview of what we offer in the department, as well as part of about our student life in the campus and in the College of Design and Engineering in general and the department in particular. So we are actually one of the largest departments in the college. We have two different programs, computer engineering and electrical engineering. Both are very, very well regarded by the industry as well as in academia. So we are a very popular department, and our students go on to do great things in their life and in demand in the industry. So welcome, and we will be here both after this information session. Please join us at the back there. We have posters set up talking about different specializations. There's some refreshments and so on. So any questions that you have, we would be more than happy to answer all of those. So please come down and feel free to interact with us after this, and we'll be happy to answer any questions that you may have. Thank you for joining us today, and now I'll hand over. Thank you very much.
Thank you, Biblab. So next, we will share with you our curriculum, and our deputy head for undergraduate programs, Professor So Wee Seng, will share with you.
All right, good afternoon, everyone. Okay, can you hear me from the back? Very good. Okay, it's very nice to see such a big crowd here today. Very warm welcome, and congratulations to students who have been offered a place in our programs. All right, so my name is Prof. So Wee Seng. I'm the undergraduate programs deputy head, right, and also student life. All right, so to start with, let me show you a video about what is electrical and computer engineering.
Electrical and computer engineering encompasses a range of fields that form the backbone of our modern digital economy. At NUS, we offer 2-degree programs in electrical and computer engineering. Students on both programs get to work on projects covering themes from Internet of Things and autonomous systems to energy sustainability and smart healthcare. Some students have even designed and built satellites that have been actually launched into space.
From the processors that power our mobile phones to autonomous vehicles and augmented reality, electrical and computer engineers are behind the most transformative innovations. Electrical engineers create technologies from tiny microchips to electric vehicles to nationwide power grids that use electricity and electromagnetism. Computer engineers build intelligence into ever smaller, smarter, and more powerful devices that enrich modern life.
At NUS Electrical Engineering, there are a lot of opportunities for hands-on learning. For example, the lab modules in which we build and experiment with electrical circuits really help me understand and appreciate the theory. There are also a lot of opportunities to learn different coding languages, skills that are highly sought after by employers.
NUS ECE offers many focus areas for you to develop your strengths and interests. For 2 years, I was president of the ECE Undergraduate Student Council. There, I developed my leadership abilities, organizing school events such as the internship and career fair. Through the modules I've taken, I've learned various skills critical to the AI field, such as machine learning and natural language processing. These skills are highly relevant in the career that I'll be pursuing after graduation.
At NUS ECE, students plan their education to match their interests and career aspirations. We combine a strong emphasis on learning the fundamentals with a high degree of flexibility, mixing education, business, and research opportunities. Our students can also embark on various industry tracks and specializations, from AI and data engineering to robotics, as well as in exchange programs and entrepreneurship opportunities at NUS overseas colleges. Electrical and computer engineering opens up a world of discovery, preparing you for careers that are full of exciting challenges. ECE graduates work in fields such as research and development, design, manufacturing, banking, management consulting, and software development. Some alumni have even launched their own businesses that find innovative ways of applying electrical and computer engineering technologies.
Our programs are designed to develop versatile engineers primed and ready to work at the cutting edge of the digital economy and the smart nation. Join us for an inspiring university experience, preparing you for an exciting career that innovates for the future.
All right, so I hope that gives you a good introduction to what is electrical and computer engineering. So as Prof. Bilap has mentioned, we're actually one of the largest departments in the College of Design and Environment. We have 70 faculty staff, and we also have close to 30 plus adjunct professors who are actually from the industry and research institutes. So they can actually inject some perspective from the industry into our courses. In ECE, we offer 2 full-time undergraduate programs. So we offer the Bachelor of Engineering in Electrical Engineering, as well as the Bachelor of Engineering in Computer Engineering. For the Computer Engineering degree, it's jointly offered by our Department of ECE together with the Computer Science Department. Our ECE family consists of close to more than 2,000 students at any time. So we have 1,500 full-time undergraduates across the 4 years for both the EE program and the Computer Engineering program. So that translates to about 200 students for each program each year. We also have more than 300 PhDs and master's research students, okay, as well as 400 plus Masters of Science graduate students who do coursework for their degree. Now, what do electrical engineers do? All right. So electrical engineers design, develop, and build technologies that use electricity, electronics, and electromagnetism. Sometimes we do get questions whether our electrical engineering program actually includes electronics. Right? So electronics use electricity, right? So the word electronics. So it's under electrical engineering, of course. So electrical engineering, from the name itself, maybe you think it only includes power and generation distribution, but it's actually much more than that. It's a wide-ranging discipline, right, covering topics from nanoscale all the way to very large scales, such as computer networks, Internet of Things, and so on. All right? Yeah, so it includes quantum mechanics, nanomaterials, nano devices, integrated circuits, right, microprocessors, okay? And also we have computers, right? Computers are actually designed by electrical engineers. We also have AI, machine learning, right, robots, and autonomous vehicles. If you look in the past few decades, you'll find that electrical engineering actually underpinned the rapid economic growth in recent decades. There are many things which are designed and invented by electrical engineers, which we have taken for granted, right? So telephone, right, today is so convenient, right? Radio, TV, electrical appliances such as the fridge, microwave oven, which every household will have one. And electrical engineers also invented the microprocessor. Right, without microprocessor invention, there wouldn't even be computer science, right? Yeah. So for communications across large area, right, maybe even across continents, so you need to have very fast internet transmission. So optical fibers, right, is actually invented by electrical engineers as well. Then if you look at your smartphone, right, wireless cell phones, so that's actually an electrical engineering invention as well. So today we have a smartphone and everyone will have one in their pocket. Then other areas that you may not be aware of will include medical, let's say, imaging, right, such as the magnetic resonance imaging. So that also is a contribution made by electrical engineers. Okay, doctors actually don't invent all these medical devices. They need to work with engineers. And if you do, let's say, pure physics, you also cannot develop that into a product. So you need to have electrical engineers, right, to come together with doctors to come with such medical devices. Okay, and looking into the future, right, there are lots of opportunities and challenges for our electrical engineers graduates, right? So, so we know about mobile devices. They are getting smaller, but much more powerful, even more powerful than a simple PC, right, decades ago. And today we have also the rise of AI and machine learning. I'm sure everybody knows about ChatGPT, right? And many of you may have already tried ChatGPT and be impressed by it. So there are challenges, but there are also opportunities. Okay, so we also have autonomous vehicles. Now you see more and more trials of all these autonomous vehicles on the roads. So they also involve electrical engineering algorithms and so on. Okay, quantum computers is also rapidly rising. Okay, and that will be actually a huge revolution, right? It will actually make computers much faster. Okay, then robotics, wireless communications, moving on from 5G. Actually, now the research is into 6G for even faster communications. And of course, renewable energy and data security. All right. So, how about computer engineering? Now, because the electrical engineering is such a wide discipline, right? So, computer engineering actually branches out from electrical engineering. It integrates several fields of electrical engineering and computer science that's required to develop computer hardware and software. And you'll find that the knowledge of hardware actually put you at an advantageous position compared to, let's say, if you specialize in purely software, right? If you are a graduate from computer science, for example. Okay, so today, with the rapid rise of AI, right, machine learning, you'll find that AI can automatically write software code. So if AI is so powerful that they can write code easily, then that might actually reduce the job market for software engineers. But if you know both hardware and software aspects of things, then that really put you in an enviable position. So for our computer engineering program, it's actually a specially curated program, whereby there are some courses which are designed specifically just for this program, right? And that's on top of the electrical engineering courses and the computer science courses that they can take. For those of you who have attended the talk just now at the CDE auditorium, right, LT7A and Engineering Auditorium, so you have seen that the curriculum is now very flexible, okay? So to graduate from the engineering degree, right, you need to take a total of 40 courses, which consists of 15 common curriculum pillars, right? And under the 15 common curriculum pillars, it includes 6 general education pillars, which the university thinks that is actually very important for undergraduates to have. And beyond that, you have 7 common pillars, which are actually stipulated by the college. College thinks that as an engineer, you need to possess all these skills, right, such as knowledge of artificial intelligence, design thinking, project management, and so on. And then we also have integrated project, right, which is a final year project, FYP, equivalent to 2 courses that you integrate all the things you have learned, right, in this project, right, to see how you can actually apply all these hands-on to come up with some design. And beyond the common curriculum, you also need to have 15 courses for the major. All right, so later on, I'll be elaborating more about what is actually inside these 15 courses. And the flexibility of our curriculum is that you have 10 unrestricted electives, right? So there are 10 of them, and you can actually use them, right, to design your own pathway, as I also share a little bit after this. Now, for those of you who have a polytechnic diploma degree, right, so you come in, then you'll be granted 36 units of advanced placement credits. So for graduation, right, for the degree program, you need 160 units to graduate. So 38 units is approximately 1 quarter. So it's equivalent to like you have already 1 year of courses that are accomplished. All right, so as mentioned, the curriculum is very flexible. So it actually offers you lots of opportunities, right, for you to plan your own unlimited pathways. So you can use your unrestricted electives to perhaps take 2 specializations. All right, if you want, you can also use it to take a second major. You can also mix maybe a minor together with a specialization. If you only want to take, let's say, 1 minor, you can also use the remaining unrestricted electives to take some technical electives, right, if you are interested in certain areas. And if you do not want to specialize in anything, of course, you can also use your unrestricted electives to take different technical electives from different areas so that you can become well-rounded. Okay, so as mentioned, we have more than 30 majors that you can actually choose as a second major, and we have more than 60 different minor programs as well. Okay, so what can you do with this, right? So if you join us, then if you are interested to become a smart device developer, so you can actually use your unrestricted electives to take maybe 1 specialization, right, in robotics and another specialization in the Internet of Things. If you're interested in being a space and satellite engineer, you can also take a specialization in robotics as well as a specialization in space technology. What if you want to become a health tech engineer, right? So you can actually do a minor, right, in public health together with a specialization in Internet of Things. And for those of you who are interested to become entrepreneurs, maybe start own companies later, right? So you can actually be trained in designing products by going through the second major in innovation and design. So as you can see, it's actually very flexible curriculum, so you can actually plan for your own future according to your own aptitude. Now, so as mentioned, we have 15 courses requirements to satisfy the major, right? Yeah, so this table actually shows the comparison between electrical engineering and also computer engineering. As you see, about half of the courses are actually overlapping, right? So for the first 5 courses, there are 3 math. Sorry about that. Yeah, so there are 3 math modules, so they're actually identical. Then you have engineering professionalism, industrial attachment. Then for the 2 courses on the electrical engineering principles and practice, 1 and 2. For computer engineering, we have the equivalent, computer engineering principles and practice 1 and 2. So actually, out of these 2 modules, right, one of them is actually quite similar to the other one. Now, you also have signals and systems, which are very similar across the 2 programs. Then digital design, right, actually is the same module on both sides. And then the remaining will actually differentiate you between the 2 different programs. For the electrical engineering program, so you find that you have 2 technical elective requirements. So some of our students actually also take up computer networks, which is actually an EE-coded course as well. For our courses, we have a strong emphasis on fundamentals as well as aspiration learning. So in the courses, usually we will include some project component, right, for you to implement some hands-on, train on your hands-on skills. Here's a list of the electrical engineering technical electives that you can choose from. So you can actually have lots of opportunity to go in depth to specialize in different areas. There are actually more than 40 technical elective courses offered by the electrical engineering program. And for the computer engineering technical electives, right, so you see that there's a mixture of CS-coded module, which are offered by the computer science department from the School of Computing, and there are also many EE-coded modules which are offered by our electrical and computer engineering department. For the EE-coded modules, actually, they are also from the list of the technical electives which are offered by our electrical engineering program. Now, our curriculum makes constant adjustments to the needs of the industry. All right, so in the recent current academic year, so in fact, we have 4 new specializations which are approved by the MOE, Ministry of Education. All right, so from the industry, we see that there's actually a sharp demand, right, a huge demand for semiconductor trained graduates. All right, and then today you also see there's a rise of the electric vehicle, right? So there are more and more electric vehicles out there. And we also have Internet of Things, robotics, and a lot of companies are actually looking at how you can actually implement all this in Industry 4.0. And if you have been catching up with the news, you find that Singapore government also invested $150 million in space tech R&D. So with all these demands that come from the industry, so we adjusted our program and we come up with new specializations. So currently we offer 6 specializations. The first 2 that are shown here, the Internet of Things and the robotics, they have been already in place for about 5 years. All right? And the remaining 4 specializations, Industry 4.0, Space Technology, Advanced Electronics, and Sustainable Electric Transportation, they have been just approved in this academic year by MOE. Then for those of you who are interested in AI, machine learning, so you can also choose a minor in data engineering, which is also offered by us. So it allows you to make sense out of data, because today there are actually more and more data that are generated from the various devices. Now, you learn about embedded systems in our courses, right? So, you actually have the opportunity to maybe work on nanosatellites. We have a world-class satellite technology and research center called STAR. Some of you understand that you'll be actually visiting STAR later on after this talk. We have a satellite which is launched just 3 weeks ago called Alumni 4. It was launched from India. And some of our undergraduates were actually involved in this development. Then another project that I would like to highlight is actually the Team Bumblebee. So Team Bumblebee develops underwater vehicles as well as surface vessels. Our students actually do it as part of the second major innovation and design program. The Team Bumblebee is actually a very special program because it's actually managed fully by students. Later on, you'll hear from our panelists, one of our current students who is actually in Team Bumblebee. Team Bumblebee has been around for about 10 years or so, and they have been building many underwater vehicles and surface vessels that they bring for competitions. And they have been winning major prizes over all these years.
One of the main challenges of designing an autonomous system is knowing what you should be doing at the right place and at the right time. If we are just dropped into this competition, we should be able to go and do at least a few tasks without me having to code anything. That is actually very difficult to do.
All right. So if you are interested in medical technology and healthcare, right, you can also work on medical and healthcare related projects. So we have students who were from electrical engineering as well as computer engineering, right, together with our faculty members who started a company on developing this product.
General Hospital, she was recommended to sign up for telerehabilitation. It's a low-cost program that uses real-time video conferencing, allowing therapists to treat and communicate with patients in the comfort of their own homes. The program is a result of a collaboration between the Singapore Millennium Foundation, the National University Hospital, Singapore General Hospital, and Ang Mo Kio Tai Hwa Kwan Hospital. Patients do exercises prescribed by therapists by following videos they can view on their iPads. Sensors are attached to the patient which transmit data and their progress via Bluetooth to the iPad. Therapists can find out if their patients are doing their exercises correctly and inform them if they're not. They can also check for anomalies using the data or watch recordings of the exercise.
All right. So during COVID years, our staff has also been involved in fighting the pandemic. So actually, Prof. Tay, he's actually one of the 3 gentlemen who is actually shown here. Right, so this device actually helps to monitor the workers' oxygen level, right, when they are actually staying in the workers' dormitory. Right, so in real time, the measurement readings will actually be sent to some centralized computer system, right? And if let's say there's any one who has low oxygen level and requires attention, then you'll be highlighted to the doctors on site. Okay, for special programs, right, we have double degrees, second majors, and minor programs. So we have structured double degree programs whereby you can do an engineering degree, then on top of that, you can actually get a bachelor in business administration as well. So for such double degree program, normally it runs for about 4.5 years to 5 years. All right. So there's also engineering, together with another bachelor degree from the College of Humanities and Sciences. So one example would be economics. And what's new is that nowadays, from this year onwards, there's also student-initiated double degree programs. So you can actually look more into it by scanning the QR code later on below. Okay, so for double degree program, Kwek Yi Xian, who is actually our graduate from EE, right, together with a bachelor degree in economics. So that's one example of a double degree. Okay, then another special program is engineering and medicine track. You spend about 3 to 4 years getting a Bachelor of Engineering degree in NUS CDE, and you spend 4 more years to get a Doctorate of Medicine degree at Duke NUS Medical School, and you become an engineer doctor after that, all right? So it's actually following the US model. For US model, you get a bachelor degree first, then you get a doctorate after that, right, in medicine. Yeah, so our student from computer engineering, Xi Zhi, right, she's actually the first one who is under this program. The engineering training actually makes you even more able to create even more impact when you become doctor, because you'll be able to even think of what medical device to design, right, with your engineering knowledge. Okay, we also provide global exposure for our students. So we have student exchange programs with more than 115 partner universities. NUS Engineering is also the only engineering school in the world to have exchanges with both Oxford and Cambridge. We also have NUS Overseas Colleges for students who are interested in startups. So you actually get to work in startup companies, right, in all this NOC program. And in the evenings, you can actually take courses at the nearby universities. So let's say you are in Beijing, you can actually take courses with Tsinghua and with Peking University. If you are in Silicon Valley, you can take courses in Stanford, right, and so on. So here's a list of the possible career options. So your unique training in hardware and software, right, as either electrical engineer or computer engineer, will open up a wide range of roles, such as AI data engineer, cybersecurity engineer, electronics engineer, of course, health tech engineer, innovator, technopreneur, right, if you take our second major in, let's say, the innovation and design program, semiconductor manufacturing engineer, which will be in high demand, right, looking forward because of the stiff competition between China and the United States. Okay, then you can also become smart device developer or even a full stack developer. Here's a list of some of our graduates. Right, Terrence, he's an EE graduate. He's currently a data scientist at DSO. Liner, so we have, he's from EE, and he's currently a technical product owner at Dyson. Sandra, who is a cybersecurity engineer at CSIT. From computer engineering, we have graduates Rishabh, who actually founded a company to build robots that can automatically wash the toilets in the shopping malls. Right, so that will actually save a lot of manpower. Then Edward, he's a digital business analyst at GovTech, and Raymond, right, she's a software engineer at Google Pay. Let's take a look at Terrence Neal's courses. What did he take to make him a data scientist, right? So he graduated from EE, and he took modules in computer science, as well as our EE courses, right, in blockchain engineering, deep learning, pattern recognition, fuzzy neural systems. Yeah, so all these courses actually train him the skills that are needed for the job as a data scientist. Now, I'm sure you are very interested in how much our graduates command, right, in terms of the salary, right? So from last year's graduates, right, 2022 graduates employment survey. So if you look at the table here, for EE graduates from the year 2002, so the median salary is $4,800. And you see that it's actually higher than the other major university in Singapore, all right? Then for computer engineering, right, also similar, our salaries are also higher than the other major university in Singapore. All right, so how about our famous alumni? Right, so we have Darius, who founded 2 companies. He founded the 10Cube as well as 99.co. For those of you who buy properties, so I'm sure you are aware of this company, right? Yeah, then we also have Lucas, right? He is actually one of the co-founders of Carousel. And Sui An is currently one among the top 50 richest Singaporeans in Singapore. He founded the company Expressive Systems, and he's our graduate from EE. So why NUS Electrical and Computer Engineering? In terms of the training, right, so the university trains students, right, in the general education program, so make the students more all-rounded, and you are actually trained on skills that are needed for lifelong learning. Then the college level also introduces you to the critical soft skills that are needed to be successful as an engineer, such as project management, creating narratives, right, and engineering professionalism. At the program level, for both the EE and the CG program, so you'll find that we have a lot of courses which actually offer some aspirational learning through project courses, and it also encourages teamwork because engineers need to work in teams with each other. And we also offer some core courses which are in small group teaching, right? Small group teaching, actually you get to learn much better because you have more interaction with the professors, right? Rather than large lecture theaters where the interaction will be quite limited. And many of these courses will have embedded presentation skills as well. And we also try to inject some industry influence into our courses. So we have invited industry speakers for the courses. And recently in February, we also organized an IoT workshop together with Expressive Systems. So as mentioned just now, right, Sui An, he's actually the founder of Expressive Systems. So he's very happy to come back to us to sponsor IoT workshops for our students. And we also organize industry visits for our students. So recently we have visits to AMD, Omron, and so on. And we are actually planning upcoming visits to Applied Materials and Micron. So all these industry visits will give students a clear picture of what all these industries actually do. And that will allow them to choose the specialization that's really of interest to them. Okay, and we also provide a lot of support for students who are coming in, especially for the guys who have served national service. Maybe after 2 years, you have already forgotten about what you have learned, right? Return everything back to your teacher. So we have the Math Refresher course, which will be organized in July. So we'll actually send out emails to you if you join our program to come for this Math Refresher, okay? Then we also have orientation camps for you to get to know your peers before you come in. So that actually gives you a head start. There's also iBlocks for returning NS men so that you can actually pre-take some courses right before you join us. We offer peer tutoring for core courses. So for students who actually need more help with tutoring, right, then their fellow students can actually help to tutor them. And every semester, actually, we organize some get-together. So there's get-together for peers as well as for academic advisors meeting their students. Student life, so we organize specialization talk to introduce to the students the various specializations so that they can actually find which is of more interest to them. When you come in, so we also organize a freshman welcome party for you. Right, then students also get involved in community service, looking at research exhibits, and as mentioned, they also go for industry visits. And for the upcoming graduation batch, we also organize a graduation farewell party for them. Now, for electrical engineering program only, right, if your results are good, you actually automatically receive a 10K study award, the Shannon Study Award, right? So this one you do not need to apply. There's no bond as well, right? As long as you have good A-level, poly, IB, or NUS high results, and you're a Singapore citizen, automatically you'll be offered this, right? So look out for emails, right? Yeah, we'll notify those who are actually selected for this Shannon Study Award. Okay, so yeah. All right, so next we'll introduce our students, right, who can share with you about their experience in our programs.
Yeah, so before we start, many of you have signed up for the lab tour as well as the hands-on session, right? Now, if you have signed up, but you have not gotten the sticker from outside or have not written down your name again, our staff have actually sent you an SMS. So can you please check and reply yes that you are still going? If not, we will release it to the students in the wait list. Okay, please do that soon as possible. So next, we have 5 students here that is going to share with you their experience. Okay, so the first one will be Wee Teck. So he's currently in EE Year 4. Yes.
Yeah, hello everyone. Yes, so I'm Wee Teck. I'm in EE Year 4, so I am graduating this sem. Yeah, so I'm like here to just share a bit about some of the major stuff that I've done in EE, as well as like some of the experiences that I had. Yeah. So the first 2 images on your left, right, is actually me on my 1-year NOC trip to Stockholm, Sweden. Yeah, so there I actually intern with a company as well as do some like part-time modules with KTH, which is a partner university that we are partnered with to do like some entrepreneurship courses. Yeah, so the 2 pictures in the middle is like some of the projects that I've actually done on for the IDP projects. So the one on the top is where I did a module whereby we designed satellite systems to, for example, monitor a local area like over a period of a year. Yeah, and the project below was actually a 1-year-long project where we actually built a rain detection device. So it lowers down the rain screen automatically when it predicts that rain is going to happen in the next hour, in the next 30 minutes. Yeah, and the 2 images on the left is actually some images from my my specialization, which is the Internet of Things. Yeah, where I had to program and make like IoT systems to. So the project above was actually to detect the light changes and to relay that information to the different IoT devices. Yeah. So there are some of the major projects and the stuff that I've done here. Yeah, I'll pass the time to Isabel.
Okay, next one we have Isabella. She's from computer engineering.
Hi everyone, thank you Wee Teck. So I'm Isabella, I'm from CG, and so why I chose CG is because like at the start I don't know which direction I should go to. I'm interested in, CS and EE, so I realized CG is a good choice for me because it has a good mix of hardware and software, and it indeed has good pay. So yeah, I think it's one of the best pay in CDE. Some of my CG life so far that I'll be sharing. So I have a pretty niche hobby, calligraphy, and we have this calligraphy club in NUS. So this is me doing Chinese New Year and Lantern Festival writing. And I was the president of ECE USC, the undergrad student council. So if I remember correctly, ECE is actually one of the few departments, if not the only one, that has student life, student affair in CDE. So like among the medical and biomed engineering, ECE is the only one that has student life affair directly under our department. So the department really care about the students, and that's why we exist. And we have held freshman welcome party, career fair, graduation party for batches, and we have this SSLC where we gather feedbacks from students and we feedback to the prof through cohort representative. So next, I live, for the first 2 years of my uni life, I lived in Ridgeview Residential College, which it focuses on sustainability, and we have activities like bird watching, kayaking from Pasir Ris to Pulau Ubin. And my neighbors are all environmental enthusiasts, talk about snakes and insects all the time. Yeah, but we have a computer building workshop, which is why I'm there. Okay, so I'm from Bumblebee. It is very frequently mentioned by CD nowadays because we won the champions of RoboSub and RoboX. We won the champion of RoboSub competition, first runner-up for RoboX competition. What we do is we go to Australia for a manned surface vessel on the top there, where we fly the drones from the surface vessel and we land the drones on the landing platform, all autonomously done. And in the middle, this is us going into the Blue Mountain in Australia. We often joke about going to Blue Mountain if we can't go to finals. In the end, we still go to finals and go to Blue Mountain at the same time. Yeah, a lot of fun times where I get to practice what I learned in the classes and apply it in my robots. And yeah, I have a lot of so this is a special part of my sharing, where in the CG, in the first year, it's all co-mods, and we have some sort of groups with fixed timetables that we always stick to each other, and then engineers, we're sometimes a bit shy, sometimes a bit introvert, a bit geek, and hard to make friends. And I came in at the time of COVID, and so it's purely Zoom university with no orientation or whatsoever. But I still managed to have a very close group of friends through CEG courses, and I really appreciate that. So I'm sure you can find good friends in CEG too. So currently I'm interning at Airbus under Advanced ATAP program, which is a computer engineering, CS internship program. And you can see we are doing our daily stuff here. I guess it's just pretty interesting. We deal with aircraft sensors data, and we do predictive, let's say we predict faults on the aircraft so that we can repair it right away to reduce turnover times. So we work as Singapore Airlines, Scoot all the time. Yeah, so that I think I had a lot in CG outside of classes, and even if you don't really have a lot of CCAs or extracurricular activities, but just for the classes, you can still have a lot of fun things. So these are all from my modules, where you can build robots and you can do a lot of coding and programming, a lot of hands-on. So I came in not knowing anything about CS or E or coding, no background. So now I know I discovered my interest in robotics, made friends, explored life, leadership. So I hope this can be you too. Yeah, thank you.
Thank you, Isabella. Next, we have Jerome from Electrical Engineering. So Jerome is a double degree student.
Thanks, Isabella. Hi, everyone. I'm Jerome. So I'll be going to my actually 5th year here in NUS this August. So personally, for me, I'll be sharing on 3 main points. The first being the double degree program. The second being a student exchange, where you get to go overseas without your parents. You can do whatever you want for 3-4 months. It's a lot of fun. And the last thing is about staying on campus itself. So it's the UTown College program, which I stay at Tembusu. So first off, I'll just touch a little. The double degree program, I did mine in electrical engineering as well as economics. So I would say that definitely from my experience, the profs and the admin staff in electrical engineering are very friendly, and they are very willing, to help you with your module planning, with your questions that you have. They're always very approachable. And I also have made a lot of friends within electrical engineering. We have labs. For those who have maybe had chance to try a resistor, capacitor, there are many times where me and my friends will sit in the lab and we'll just blow a capacitor. Not because we want to, but because we don't understand what's going on. And then that's how you learn as part of the process. Sometimes we are doing some coding and then we spend 5 hours just to realize, as you know, right, you're missing a comma over here, or you forgot a space over there. And that just, bonds us a lot as electrical engineering students. Yeah, and I think if you guys are planning for any second major, second minor, specialization, I think it's good to explore, but do a bit of planning for what modules you need to take, and definitely, take chance of it, right? You're here in NUS for 4 years, explore as many programs as you want, take up those that interest you. You don't like it, change it the next semester, and it's still fine. So I'll move on to my second point. So the second point is on the student exchange. So ECE has a lot of partners overseas. I have friends who go to Korea, go to Japan, some go to Europe, KTH if you've heard before. And I personally went to University of California, Los Angeles, so UCLA. And it's very, very interesting, right? I go over there, you really explore a different way of living, a different perspectives that people have over there, and very different teaching, right? Over there, so when you come to university, you might have exams where we call it open book, where you can kind of have notes prepared so as to aid you while you're doing your exam. Over there in the US, they have open book, open laptop, open internet. During the 2-hour exam, are people watching the YouTube recording of the prof teaching one of the lectures just to answer the problem? It's a different mindset, right? But ECE having this opportunity for exchange allows you to exposes you to go there and just to see how other people work, right? I also was very confused why they would have it, but when I asked people there, they said, well, the point is, even if students don't learn or don't revise the day before, at least maybe hopefully on the day of the test, they would hopefully revise a little. And that's the reason why they have open laptop, yeah. But they do them, we do us, and it's just really an exchange where you get to meet difference. And I think it's just the exploration over there. It was during winter. I went snowboarding, I went skiing, I went surfing. If it's the national parks, I flew all the way towards the East Coast to see New York a little, and it's just a lot of fun. So thirdly, it's about staying on campus. I urge any of you who are considering to actually just apply either to the halls or to the residential colleges. I had mine at Tembusu College where I stayed for 2 years. You meet people from the different faculties. You get to have a lot of interest groups that you can join. You like some music, or you like sports, or even some niche interests that you have, aviation, whatsoever. Sometimes you can even start a small little club at this on-campus accommodation, right? And for me, I think there is where it really helps to complement the engineering lifestyle, because engineering can be a bit difficult. I won't say can be, it will be difficult, but that doesn't mean that you won't be rewarding at the same time. But the point is, when you couple your engineering experience also with your on-campus experience to see other people, to just try different activities and put yourself out there, it really just helps you to explore who you are as a person and where you might want to do for a future career, or even just explore with others who have very different perspectives, but both are still very valid on the same issue. And with that, I really hope that as you guys are considering, to not just consider the degree program you have, but also to consider what does this university offer you. We will share different aspects, and it's really what else that can plus onto your degree program. You will have a degree, no doubt, but what else can you do? And I would say that you can do a lot in NUS.
Thank you, Jerome. Next, we have Joshua from
thank you.
Computer Engineering.
Thank you, Jerome, so much for the sharing. And I'll be sharing more about the poly life transitioning to uni life. So I don't know how many of you here are from poly, but I was from Singapore Poly, and I was from aerospace electronics, and I came to computer engineering. So some of you may say that aerospace electronics and computer engineering are quite different fields, but actually most of my modules, especially the hardware modules, are quite similar. So a lot of stuff I learned in poly can be applied to what I've learned so far. And I remember one of the labs that I did for my year one is that the first lab that I went to, I remember, because in poly I already learned it, so I was the first to leave the lab. But by the end of the lab, I was the last. Yeah. So towards the end, I was the last to leave because in uni, the workload is a lot heavier. There's a lot more content. So it is tougher, but it's not impossible. If I made it through year one, I'm pretty sure all of you all can make it through year one and through uni even. So there's a lot of time management, a lot of, you have to be very independent. You have to, a lot of self-directed learning. You have to make use of all the opportunities to, go and, like what I think what they say and what they have done is to take up the initiative to go for all these workshops, all these programs, and nobody's going to fault you for not doing anything. But I think while you're here in uni, before you go and work, make use of the time to go and explore the CCAs, non-academic life as well as your academic life. And I remember I went to an expressive workshop, and that was where I met Prof. Arthur. And he shared a lot with me about his project. And so it's all these connections that you make in uni that really help you. And because of that, he gave me the opportunity to speak today with all you guys about for my transition from poly to uni life. And also, the professors here, they have a lot of experience. They have a very profound knowledge in their field. So go and speak to them. Go and find out more information from them, as well as seniors as well. Yeah, and make friends in uni. And speaking about industry experience, I'm currently now interning at DSTA. I think there are some DSTA scholars here. So DSTA stands for Defense Science Technology Agency. And over there, they do a lot of procurement, acquisition, and upgrading of platforms in Navy, Army, and Air Force. So a lot of helping MINDEF to develop technologies to upgrade our defense capabilities. And I'm currently doing infrastructure as code for cloud commercial. So under MCC, MCC stands for MINDEF on Commercial Cloud. So I don't think I can share too much information because there are quite a lot of sensitive data. But in general, what I'm doing is I'm working with AWS. So AWS is Amazon Web Services. And yesterday, I just attended a workshop. So in internship, even there are opportunities to go for workshops, to learn, to go for certifications, and really just make use of all these opportunities to build your portfolio, to as well as spend some time with your family as well, and make friends. And yes, academic is one thing, but I think the non-academic side is also as important. So with that, enjoy your uni life. It's quite exciting, and do manage your time. If you need any help, you can always look for us, and we will help you with whatever queries that you have. With that, I'll just end my sharing, and I'll pass on to Jeremy.
Thank you, Joshua. And last we have Jeremy. He's from electrical engineering, and he's in the e-scholar program.
Hi everyone, so I'm Jeremy. I just graduated this semester and I'm in electrical engineering. I was in electrical engineering. So I can just talk a bit about why I decided electrical engineering. So I think first of all, engineering, I'm not sure most of you might be coming from a STEM background. So I was from a STEM background back in JC, and it's something that I wanted to build upon. It's a good way to continue this is through engineering. And it's not just technical skills. I think when you come into engineering, whatever engineering degree it is, you get the rigor of the program gives you the analytical, the problem-solving skills that you can generalize in the future, whether you want to do engineering, banking, project management, all these different things. I think these are skills that you continue to take away and use whatever discipline from engineering. Electrical, honestly, it was more a process of elimination than anything else. I think I knew I didn't want to do mechanical, I didn't want to do chemical, so I eventually narrowed down on electrical. It was very relevant then, and it will be very relevant in the future. I mean, you have the advent of, I think just now Prof. So talked about IoT, Industry 4.0, ML, hardware and software, both these things EE will train you very well in. So let me talk a bit about Engineering Scholars Program first. So the Engineering Scholars Program is actually an NUS scholarship program, so they'll pay for your studies, bond-free, don't worry. So it's an accelerated program. So you do your bachelor's in 3 years, and you do your master's in your 4th year. So for me, I finished my degree in 3 years, and actually this coming academic year, I'll be doing a master's in NUS. Alternatively, you can do a double degree program, so a bit like Jerome, but you do it in 4 years, and NUS will pay for it as well. So that's NUS Engineering Scholars Program. And besides, I guess, the money benefits, there's also the community benefit as well. So you get paired with very really great academic mentors and admin support staff who help you to plan and strategize to make the best use of your NUS journey. And a part of that also is the eScholars community that you get to be part of. So I had seniors who have helped me so much in planning my modules or giving me academic help, and even friends from different engineering disciplines who you can do projects with, who you can really make lifelong friends with. Yeah. So another benefit of eScholars is that you get to be part of RC4. So I think Jerome and Isabella talked a bit about the UTCP, Utown College Program. So a bit about that. It's not just a place to stay. So it's not just like hall where you stay for 1 or 2 years, but you also do modules in your UTCP, whether it's at RC4, Tembusu, RVRC. So you do modules in it. And each college has a specific focus. So RC4's focus is systems thinking. So you do modules on systems thinking, critical thinking, writing, and communication. And these modules are actually very refreshing to kind of complement your more technical electrical engineering or computer engineering modules. Apart from that, you also get to play, live, eat with your friends. One big part is interest groups. So whether you have any background in sports, arts, even things like cooking, coffee making, you get to join an interest group and hang out with people who are like-minded. So this was, I think the picture on the left is actually me and my friends participating in inter-college games. Yep. So another key highlight of my NUS journey is the NUS overseas colleges. So I went for 1 semester in NOC Munich. So for 6 months, I was actually in Munich in Germany, where I studied entrepreneurship, innovation, and business in the Technical University of Munich, which is actually one of the top engineering schools in the whole of Germany. And besides that, I was also interning. So in Munich, I interned in an electrical engineering startup that was doing battery management systems. So I did things like embedded software, hardware development, business development. So these are all the different things that you'll be learning along the way through your modules that you actually get to put into practice and kind of see the motivation and the appreciation behind what you're learning. So this is a picture actually of me and my friends in Munich. So other than just the work stuff, you get to play. And me and my friends, we kind of had a pact where we will say, okay, since we're only here for 6 months, every single weekend we'll go to travel to like a different state or a different country. So we did that every week. It's really tiring, you don't sleep, but it's worth it. It's definitely worth it. So these are kind of the different opportunities that you get. So this was on some ice mountain. So very nice. Now Singapore going to be 40 degrees, so you can go to this kind of place. Very, very worth it. Yeah, so other than this, let's talk a bit more about the work stuff. So this is actually a picture of me doing my internship in Stable. In Munich, sorry. So you can see all the battery racks I was coding. So these are kind of real world projects that you get to be exposed of. So you're not just learning technical skills, theoretical, but you actually get to put these theories into practice in whatever work you do. And there are plenty of opportunities to do that, be it modules, projects, practical projects in your modules or internships. Yeah, you can even do things like internships or workshops during the summer breaks and things like that. And lastly, this is actually me in my final year project. So I just completed my final year project. It's on visible light communication, and we actually got to do it and deploy our system in a multinational corporation. So this is actually a logistics warehouse where we are deploying our system. I can't go so much into detail about this, but basically the point being that for this final year project, it's not just, you do your work and then you put it in a box and then it's shelved, but you actually get to deploy the system, you actually get to put it into use, get to see its practical benefits. So I guess the point that I'm trying to make and all of us are trying to make is that one key thing about this journey is flexibility. When you come into NUS, be it EE or CEG, the 4 years ahead of you, you have so many different opportunities and you kind of craft your journey and your academic plan according to that. And it's how you want to make the best use of it. If you're more interested in robotics, go ahead and pursue that. If you want to go overseas and try out different cultures, experiences, then you can go ahead and pursue that. So I think at the end of the day is what you want to make of this journey. Yeah. So I think with that, you guys are probably tired of hearing so many different people, so I'll just pass the time back to Prof. Tay.
Okay, thank you everyone. So I think we will be here. So if you have any question, you can come down and chat with them. But I would also like to invite everyone to have some refreshment outside. And for those who have signed up for the tours, can you please go and collect your stickers? And then we will inform you when we are ready to move to the labs. So we also have many professors that are here. They will be stationed outside. So if you have any question, you can also talk to us. We also have our different specialization posters. So maybe you can find out more information regarding that as well. Thank you very much for spending your Saturday afternoon with us today. Thank you.